Do you know what link flaps are? They're small events that have a massive negative impact on data centers, especially AI data centers. If you want to find out more, stick around and we'll check it out. So what is a link flap? Simply said, a link flap is a network connection that transitions between the up and down state. In other words, it disconnects, reconnects, and maybe does that over and over again. So does that mean link flaps have got something to do with CRC errors and a high bit error rate? Well, no, because CRC errors, they indicate corrupted frames, whereas the bit error rate, well, that is a signal quality metric. And in both cases, although corrupted, the data actually arrives. However, having said that, the CRC and bit error rate, well, they are actually very good indicators and early warning signs for a potentially upcoming link flap. Now, why are link flaps so much more critical for AI data centers than for traditional data centers? And to understand that, let's have a closer look how AI data centers work. Now, AI data centers, they're these high performance, high throughput environments that rely on low latency and highly reliable links. And that is the critical part which makes link flaps so problematic. Because if we're thinking about a large training model, AI training model, we're actually using hundreds or even thousands of GPUs together on that one training job. And if only one link, so node link of that cluster actually flaps, well, that can result in that complete training job to stall, or in worst case scenario, even crash altogether, meaning we would have to restart it again. Also, the AI workloads, well, they are often using distributed frameworks. And these distributed frameworks, they rely on all of the nodes being reachable at any given time. And if that's not the case, well, that can result in node drops, retries, or inconsistent states. And last but not least, the GPU resources, so the hardware itself, is very expensive, meaning that we want to make sure that we use the GPU resources as efficiently as possible. So in other words, we need it to be running continuously, but if we've got an unstable network, that can result in GPU resources sitting there idly. So put differently, why are link flaps so critical? Because they can very, very quickly result in hundreds of thousands of dollars extra cost per month. And that's definitely something that you want to avoid. So what is an acceptable link flap? I mean, ideally we would have no link flaps at all, but realistically speaking, that's not possible. So in a traditional data center, a link flap rate of equals or less than 1% is considered acceptable if it is a non-reoccurring and isolated event. However, if we're talking about AI data centers, that by far isn't enough, because even a link flap rate of equals or less than 0.01% per month is actually still considered as unacceptable, especially for the links GPU to GPU or network interface cards to top-of-the-rack cabling. So what causes link flaps? Well, of course, there is not that one root cause. Instead, we've got multiple potential causes. We're talking hardware issues and failure, going from cables to connectors to the actual equipment. Equipment misconfiguration or software and firmware bugs, which will cause the ports to go into a reset. Or we've got overheating and unstable power, which can make marginal links turn into flapping links. But there's also one other potential link flap cause that a lot of times is overlooked, and that is the transceiver interoperability. What does that mean? Well, normally if we think about transceiver interoperability, we're thinking about the transceiver working properly in the equipment that it is being plugged in. And on the other side of the link, well, we'll just use the same type of transceiver, so LR4 and LR4. But to achieve the link flap rate that is required for AI data centers, we need to go further than that. In that case, we actually need to make sure that the transceivers on either side of that optical link are working flawlessly together. And to achieve that, it can actually be necessary to fine-tune the chipsets or the DSPs of the transceivers to achieve that level of link flap performance. Now, if you've got a data center where, on the one hand, the GPUs and network interface cards are from one manufacturer, and you're using their transceivers in that equipment, and you've got the switches from a different manufacturer, and you're using their transceivers in that equipment, then it can be quite a challenge to get them to fine-tune the transceivers to each other. And in those cases, it is actually the best situation to use a neutral transceiver suppliers, such as HUBER+SUHNER, because we then can make sure that we can fine-tune the transceivers to each other to achieve the best possible link flap performance. So in any case, make sure to contact us. So, I hope you enjoyed this video and that you learned something today. If so, please leave a comment. And of course, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye.